All right, I am going to go over how I found all of the side links and whatnot and coordinates for benzene. This is benzene. You can't tell because I drew it as if it was cyclohexane. Anyway, we have all of the little 30, 60, 90 triangles that are shown in red. That is because every angle here is a 120-degree angle. We are allowed to estimate that it is a 120-degree angle for the hydrogens because I said so. I did not look up the exact angle. Anyway, we know that 30, 60, 90 triangles have specific lengths. Here's me making typos about it. Kind of. We know that the hypotenuse is 2x, the shortest side is x, and the middle side, that's the long side but not the hypotenuse, is x times the square root of 3 or square root of 3x, but that sounds a little confusing. From there, we can take the known side lengths of the carbon-carbon bonds in the benzene, and we go, okay, so 2x equals 1.39 angstroms. I'm doing everything in angstroms because I want to. Then x equals 0.695 angstroms. And x times square root of 3, put that in your calculator. I typed out all the values. I will not be doing that the next time because that's gross. Now I'm just labeling them for you so you can see them later. I hope I can figure out how to remove the clicking sound from the video. It's kind of annoying. I'm just filling space. All right, moving on to this triangle that I'm terribly outlining. We know that the CH bond length is 1.09 angstroms. Hopefully. I looked it up, but we'll see if that's right. So 2x is 1.09 angstroms. X is half of that, like 0.541. Let's see if I was right. Nice. And x times square root of 3, I'm not calculating that one in my head, but it's 0.937 according to me 2 hours ago. It's a lot longer than that, but I rounded this one off because I didn't feel like typing in all of the things. We have to round it off later anyway. Now I'm typing in all of the side lengths for you guys. Honestly, it just makes the page more crowded. I should have made you guys write it down and remember it instead. That's okay. Yeah, so that's basically all of the miniature measurements that you need. It's the measurements you need. It's just not on a grid yet. I'm going to put it on an XY coordinate plane, I believe it's called in the math world. For the video that I posted where I actually put the measurements into Molekel, I used X and Y the opposite of what I did here, but again, it doesn't really matter. Oh, look at me struggling to draw that straight line. Now you can't see the hydrogens here, but I figured we can all figure out. If you're advanced enough to be like, yeah, I'm going to be using Molekel, I assume that you can understand that there are hydrogens there. I'm being so sassy today. That's okay. Okay, here's my pretty badly drawn plane. Pretend that it's centered. Labeling my X and Y axes. Wonderful. All right, now because we know the height of this is 1.39. No, it's not. I lied to you. Yes, it is. I forgot how I calculated that. So you guys are going to have to figure that one out on your own. But I figure from the 30, 60, 90 little tricks, you'll be able to do it. Then here we just add the 1.39 to the length of the CH bond. Oh, I remember. The height is just 2 times x because that's the short base, and you have like 2 triangles essentially with that base on this line, and that's why it's just equal to the bond length. That's not necessarily true for all shapes. I just did it here because I was smart enough to figure that out last night when I did this problem, and I kind of forgot about it now. But now you know. This is the most disorganized video ever. That's okay. Now I'm using the larger 30, 60, 90 triangle for the CC bonds to show you what the coordinates are for that second carbon. And now we're moving on to the hydrogen. I'm going a little fast. That's okay. I'm showing you the triangle because apparently an hour ago me didn't think that y'all could figure that out. Basically, you just add the coordinates from the carbon to the lengths from the CH bond 30, 60, 90 triangle. That's what I'm showing here. Add those together. Otherwise, it'll be painful. I mean, it's painful anyway, but it'll be more painful if you like try to put it into your notes and then put it into Molekel and it screams at you. I didn't do that, I just assumed. So there's our coordinates. I'm pretty sure this is the last one that I show you how to do. Maybe I do the rest. Yeah, nope, I'm saying find the rest of the coordinates on your own. Good luck. One note is that I did do this with the X and Y coordinates switched in my Molekel video because I didn't do it on Microsoft Paint originally. I think you guys can figure it out. Or you can use this and just flip the coordinate system. It doesn't matter. The coordinate system is kind of arbitrary. Anyway, good luck, everybody.